welcome to True Projects. In this video, we will be explaining about proactive fault tolerance technique to enhance reliability of cloud service in Cloud Federation environment. Introduction. Cloud Federation has evolved as a new computing paradigm allowing cloud service providers to efficiently share unused resources while meeting diverse demands. Fault tolerance becomes critical in this federated context to provide better dependability and availability of services. A proactive fault tolerance system that anticipates problems based on CPU temperature is proposed in this project. Our method approaches resource redistribution between defective and non-faulty CSPs as a multi-objective optimization problem with the goal of optimizing profits and minimizing migration costs. We present the preference-based fault management, which is PBFM algorithm, which outperforms previous methods such as MCAFM and PAFM in reaching balanced solutions for profit and migration cost trade-offs in the presence of broken CSPs. Objective. The project's goal is to improve the reliability and availability of cloud services in Cloud Federation context by implementing a proactive fault tolerance solution. Based on CPU temperature, technology tries to discover and handle errors within the federation in advance. The system tries to achieve two fundamental objectives by shifting resources from defective CSPs to non-faulty ones. These are maximizing profit for the CSPs and minimizing migration costs. When dealing with the problematic CSPs, the suggested preference-based fault management, which is PBFM algorithm, serves as a technique to achieve this optimization and provides a better solution than existing mechanisms. These are the requirements for the project. In hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. In software requirements, we need Python IDEL of 3.7 version. These are the design models for execution of the project. First one is to upload cloud dataset. In this module, we upload the cloud usage dataset containing information about available cores, CPU size and capacity, memory details of the cloud machines. Next one is to build faulty vector. This module is responsible for identifying faulty machine within the cloud environment. The technique monitors the CPU usage of each machine and calculates the probability of machine being faulty based on its high CPU usage. Next one is run PBFM algorithm. PBFM, which is probability-based fault management algorithm, is executed in this module. It uses the faulty vector generated in the previous step to predict migration machines for faulty CPUs. For each faulty machine, the algorithm selects a non-faulty machine with high throughput and memory availability for migration. Next one is faulty machine percentage graph. In this module, a graph is generated to visualize the percentage of faulty and non-faulty machines in cloud environment. For execution of the project, first open the code folder. This is the code folder of the project and this is the dataset folder in it. And this is the dataset. Here are the parameters of the project. So close this. And here is the another dataset. And this is the main code file of the project. And this is run.bat file. Without executing the project in command line interface, we have created Windows batch file for execution. So double click on it for execution. This is the graphical user interface of the project. With this, we can interact with the program, and this is created by using Tkinter library. So first click on the button Upload Cloud Usage Dataset. Select the dataset and click on Open. Here, it is confirmed that data is loaded, and here we can see few records of the data. And here, there are 8,249 rows in it and 12 columns in it. Now click on the button Build Faulty Vector button to find all high CPU usage machines and then build a faulty vector. A low usage CPU will be considered as non-faulty machines. Here, we can see machine IDs and we can also see all selected faulty machine CPU usage has crossed 100% and then build a faulty vector. Now click on the button Run PBFM algorithm button to predict migration machine for faulty CPU with less cost to increase provider profit. So For each faulty machine, we predicted one faulty machine in first. We can see PBFM predicted machine ID for faulty machine for migration. The predicted machine will be selected based on high memory availability and throughput. And if system has high throughput and more memory, then migration reading and writing will be done faster, and which will consume less electricity and result it into high profit. Now click on the button Fault Machine Graph button to get faulty and non-faulty machines. Here, x-axis represents the faulty machine and non-faulty machine, and y-axis represents the percentage of that particular machine. Among both the machines, faulty machine is low than the non-faulty machine's percentage. Here, we can see application selected best machine and then selected VM with less cost and high throughput. Exit the GUI. Conclusion. The proposed proactive fault tolerance technique in conjunction with the probability-based fault management, which is PBFM algorithm, significantly improves the dependability and profitability of cloud services in a cloud federation context. The technique optimally chooses high throughput and memory available resources for migration by monitoring all resources and forecasting the probability of defecting computers, decreasing migration time and resource consumption. Experiments on the dataset shows that approach is effective at finding problematic machines and efficiently transferring programs to non-faulty machines at low cost. Overall, the proactive method beats previous reactive techniques, resulting in more dependable and profitable cloud service in a cloud federation setting.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.